Okay, so here we are on the last unit, trigonometry. So the first little bit is going to be just some review, some things that you've already seen before, and then we're going to get into some things a little bit more in depth and some things that you haven't seen before. But this unit's really quick, just going to be 3 sections, not too bad. First thing is knowing basic trig. So these are the 3 functions you've seen before: sine, cosine, tangent. And this is likely the equation that you've seen. So sine, opposite over hypotenuse; cos, adjacent over hypotenuse; tan, opposite over adjacent. You've probably seen SOHCAHTOA before to try and remember this. And this is all relative to which angle you're dealing with. So in this case, looking at this, if this is my angle that I'm looking at, this side is adjacent, this side's opposite. Hypotenuse is always the long side. If I were to look at this angle up here, this would be adjacent and this would be opposite. It just switches. So if we look at this triangle here, so triangle EFD or DEF, doesn't really matter. So if we're looking at side DF, if we're using E as my reference angle, so we're going to say this is theta or E, we're asked here, side DF is called what? So this side here, this is on the opposite side of the triangle. So this one is the opposite. If we look at DE, so this is the long one. The long one is always going to be hypotenuse. Side EF, this one is adjacent to the angle. So this one, adjacent. And if we want to look at the value of the sine function, so remember with SOHCAHTOA, this one is SOH. So we want opposite over hypotenuse. So if we look at our equation here, our triangle, opposite is 12, hypotenuse is 13. So this is going to be 12 over 13. Cosine is this. So we get adjacent over hypotenuse. Looking at a triangle, adjacent is 5, hypotenuse is 13. So we get 5 over 13. And tangent, this is TOA. So opposite over adjacent. And again, from the triangle, we get that this is 12 over 5. So this is how you get that. We're not going to use a trig table for this. I'm not going to give you that. Using your calculator, we can solve for each of these angles. So if we've got that, let's see, sine E is equal to 12 over 13. That's just what we did here. So if we want to get E by itself, angle E is going to equal the inverse sine of 12 over 13. And this you can just plug into your calculator. So if you plug that in your calculator, you'd get 67 degrees. Again, in your calculator, make sure at the top it has a little D for degrees. If you do it with R or G, it's not going to work. So now we can do this for angle D. So we could rewrite everything in angle D. However, something that's worth noting in this is, I don't know if you've been taught this before, but if you add all the angles in a triangle, they add up to 180 degrees. So angle D plus angle E plus angle F add up to 180 degrees. You don't need to know where that comes from. You just need to know it does exist. So if I want to solve for angle D, this is going to equal 180 minus angle E minus angle F. So 180 minus angle E we just solved for, 67, minus angle F. This little box here means it's 90 degrees. So then solve that, we get 23 degrees. So there you go. For this next part here, I'm not gonna do much of these examples. Basically, don't use the trig table again. Don't worry about this. Use your calculator and solve these to 3 decimal places. So all you need to do, plug this in your calculator. I'll write down a few of these. Actually, I'll show you the key. I have them all written out here on a different piece of paper. So if you want to pause and slowly double check your answers, you can double check these. These are what you should get when you plug it in your calculator. If you are not getting these answers, then something's wrong. So you need to double check with me so we can figure out why it's wrong. Let's do the next one here, next page. So using cosine or tangent, find the unknown side and angle. So something like this might also be referred to as solve the triangle, as it says down here. If it says solve the triangle, you're solving for everything. In this one, we want to know what x is. So in looking at this, here's our angle. So that means this is the opposite side. This is the adjacent. This is hypotenuse. So what involves angle, adjacent, and hypotenuse? Well, this is going to be cosine. So cos theta equals adjacent over hypotenuse. Plug in the values that we know. 28 degrees. Adjacent is x, that's what we're looking for. We have hypotenuse. So therefore, x equals 34 cos 28. And solving this, we get 30.0. So it asks you to do it to 1 decimal place, so we put 1 decimal. Let's try the next one. Here is the triangle. This time, so here's the angle, this is adjacent, this is opposite, this is the hypotenuse. So we have an angle opposite adjacent, so this time we're doing tan theta equals opposite over adjacent. Plug in what we know, so tan 30 equals x over 40, so therefore x equals 40 tan 30. And we get this is 23.1. So there you go. Just a reminder, tan is not something that you can divide by. It's something that, it's an operation. It's like a plus sign or a times sign. You can't just divide that out. Let's try this. Solve the following triangle. We want to get this other side here and all the angles. That's going to be what this means. So anytime you see solve means find all sides and angles. That's what it means by solve. So it just means you need to go ahead and find absolutely everything in this. So I'm gonna do some labeling here. I'm gonna call this side B, I'm gonna call this side lowercase a and lowercase c, just to be consistent with the angles and what we have here. So first thing, I have all the sides. So since I have all this, I have 2 of the 3 sides. What I can use is Pythagoras, hopefully you remember Pythagoras, which is a squared plus b squared equals c squared. This only works for a right triangle, which we're doing right now. And we can solve for c. 3 squared plus 5 squared equals c squared. Therefore, c is going to equal 5.83. That's rounded, but that's what we've got for that. Then let's solve for an angle. Let's solve for, let's say this side. Let's solve for A. So we've got adjacent and opposite here. So we can deal with tan A equals, the opposite, lowercase a over adjacent, which is b. A equals inverse tan of 3 over 5. And we get that capital A is 31 degrees. And then using this rule that all the angles add up to 180, we get that B is equal to 180 minus 90, which is this angle here, minus 31, which is the angle we just solved. So we get 59 degrees. So there you go. That's solving the triangle. You can do this again for the example 5. I'm not going to do that. But this is how you can go about doing this. The unit circle here, I'm not going to go through this. You can do your own research if you really want to, but I will be teaching this in Pre-Calc 12. So I'm not going to focus on it this year. You'll get it next year. But what I will show you, and that's something that is good to know, and I'll just show it here with one of these. So if I'm looking at some angle here, theta, again, this is just going to be a teaser for next year. On a unit circle, the radius is 1. And notice here I can make a nice triangle where this is going to be my x value, this is going to be my y value. If you think of this as your y-axis here and your x-axis with a circle in the middle, you can kind of think of it like this. And then getting into triangles, you can see, so sine of this angle would be opposite over hypotenuse, which is just y over 1, and so on. This, again, this is just a tidbit for next year. If you don't remember this, maybe you'll at least think of it once you get to next year. What I am going to focus on is special triangles. So special triangles are these two triangles I'm about to show you, and this is going to help you actually solve some of these problems without a calculator. Now some universities might require that you have these memorized. You will never be given these, but you're going to have a calculator in the test. I just want to show you these, and so you get familiar with using these. You'll be able to double check your answer with the calculator, but I want you to remember these, or at least know that you've seen them. So these are two special triangles. I'm not entirely going to show you where they come from, but this is a special triangle with 45 degrees. And here's another one with 30 degrees, 60 degrees. And these are just very common equations. And you'll see these a lot, and it'll pop up in your unit circle as well. So it's good to know where these come from, because now if, say I suppose, wanted to find cos 30 degrees, what I can do, since cos 30 is adjacent over hypotenuse, so looking at this triangle, my adjacent of 30 degrees would be root 3 over the hypotenuse, which is 2. So I don't need to put this in the calculator. You can try it and see if you get this number. But this is an exact answer. Or if I did say, let's say I want sine of 60. So here's 60. Sine is opposite over hypotenuse, so the opposite of this side would be root 3 over hypotenuse, which is 2. They happen to be the exact same thing. So you can use this to solve these examples down here at the bottom. So I already did cos 30. You can use it for these. For the sake of time, I'm not going to go over that because I wanted to specifically show you this last little bit. That's actually not a part of the notes, but this is going to come important. So something else I want to show you is angles in standard position. So the reason why I want you to show you this is because some of these questions in the practice problems are going to be involving this. So if I've got my coordinate system like this, you've seen this before in graphing. if I want to graph an angle in standard position, so let's say I wanted to graph this angle. So we need to know, how does this work? So my angle in standard position always starts at this point, the positive x-axis, and is going to rotate. So it rotates counterclockwise. So going the opposite way of a clock. So it rotates counterclockwise. This is what's referred to as the terminal arm. And where you start from here, this is what's called the initial arm, because it's initially where you start from. Initial arm. So when you're asked to graph something like this, you need to start from the positive x-axis and rotate counterclockwise until you reach where your angle is. And so if I started this arm, this would be at 0 degrees if you're at the x-axis. If I rotated up till here, this would be at 90 degrees. If I've rotated all the way around to here, this is 180 degrees. If I keep rotating another 90, this is at 270. And then if I rotate back here, this is going to be 360. So if I'm looking at this, suppose I wanted to graph the angle. Let's see, what would be 160. Let's do that. So if I want to graph 160, I'm going to start from here and rotate around, and it's going to get somewhere over here. So let's do this in a different color pen so you can see this. This, starting from here, rotating around to here, this would be approximately 160. How did I get that? Well, it's not quite at 180, but it's further away from 90. So I'm 70 degrees from 90, 20 degrees from here. So it should be closer to 180 than 90. So that would be this angle, 160 in standard position. So just so you know that, it's going to come. The other thing I needed to show you with this is the quadrant. So if I drew those same quadrants out, what you need to remember is, since I'm starting from the initial position here and rotating around like this first quadrant we start in is 1, and then it rotates to 2, and then 3, and then 4. So if I'm looking at what quadrant do these terminate in, this one stopped in quadrant 1, this one stops in quadrant 2. So you'll be asked that as well. So that is this section. It's a little bit longer for this. That first part was some review, but that is chapter 1.